Okay, so I think I'm going to hit the breakout rooms. 13 participants. Oh, come on in. There's only 14 people here today. It's not too good. So
Someone just tried to come in and I accidentally didn't.
1, 2, 3, 14. We're at 13. I think we can go into 4 groups.
Okay, hold on just one second.
Yeah, it looks better. It tells you how many participants are down there too. I didn't notice that. It does the maths for you.
Yeah, how nice is that?
I don't know why we have to take this class no more. Okay, so open all rooms. Hello, hello. Let me copy this. Okay, so I'm going to text it to everyone here.
Hello, can you hear me?
Yeah, I can hear you. So I'm going to text this. So like I said, like put your name and then put your group number. So y'all are in group 2. Can y'all see that link?
Yes.
All right, good deal. I'm going to bounce elsewhere. Hello. Can y'all see that link, that chat?
I didn't see a chat link, no.
Okay, so let me do this here. Can y'all see it now?
Yes.
All
I
right.
got to it through my email, but yeah, that works.
Okay. So I believe we are in what, group 3? Is that what it says?
Yes.
Yeah, that's where we are. 3 and then 4. So let me look at group 4 and go tell them where we are. I feel like there's probably an easier way I could have done this. Can y'all see that chat? Do I need to post it like once for every group? I don't know how that works.
I see a link here. Okay, I see it. A little chat popped up here.
Do you see it 3 times or just 1 time?
I see something on the side when I clicked on the link. There's a little chat on here on the side.
Okay.
I'm in the review right now.
Okay, so y'all got linked up. So I want you to talk amongst yourselves. Make sure you're getting the same solutions for these things.
Okay.
All right. And then like put your name on there and put your group. And so y'all should be in group 4. And I'll bounce around and make sure they have their link.
Time. You will not have any more time, my friend, to yourself again. You are now on the radar. But it's just a little tip. Right? I'm trying to skip anything.
What do y'all see when you pull up the quizzes? What do you guys see? I'm just really
I'll
curious.
click join the game. It just says I need a code.
Okay, so I'm just curious to see what y'all are seeing when you pull it up, because I've never done it this way before.
But yeah, real quick, like how did you guys get the website?
Oh, she sent it on the link on the email. Basically, talking about
And
use
it's
this
also
as a study guide.
in Blackboard.
All right.
Yeah,
I'll send it on the chat. I have it copied.
Please do.
There you go.
Thank you.
Yeah. So I want y'all to go in there, and y'all are in group 1. And so put your name, put group 1, talk amongst yourselves, figure out a solution.
Group 1.
Try to get all the same solution, hopefully.
Oh, so all the questions are the same for all of us, not like mix match and stuff.
The first page of the material in the review is pretty straightforward.
It's just I couldn't connect. Yeah, they record. It's just
How are y'all doing?
So we just like
Mm.
problems, or do we have to talk about it with our group?
What's up?
Do we talk about it with our group, or should we just like do it ourselves?
I'm hoping you'll talk about it with your group and like try to like figure out things. You should have enough time to like kind of work through it and talk about it. And it kind of tells you if you're correct or not. So if one of you gets it wrong, the other ones can get it right, probably, I guess. If you're getting it wrong, I hope you talk about what's going wrong. Yeah, I was hoping to get some discussion here on what's going. What problem are y'all on?
I'm still on the first one, and
I can't hardly hear you. You have to speak up a little bit.
sorry, so I'm still on the first one, and I'm just finding out the slope right now.
Okay. First one. Yeah, I'm gonna have to start this over. Yeah. Okay. So what's your slope on the first one?
-2/3.
Yeah, that's it. And what's your y-intercept?
My y is 4.
Yeah, it should be 4. Yeah.
Well, it would be the yellow one.
Did you get it? Hopefully. Hey, I heard it. I heard the chime. That's it. Next one's a word problem. I want you to interpret the slope and y-intercept. Is Gabby and Aurora around?
Yeah, I'm here.
Okay. Okay, so what about the next one? What's the slope and what's the y-intercept?
Would the slope be the 42?
I can't hardly hear you. You have to speak up just a little bit more.
Sorry, would the slope be 42?
Yeah, that's it. And what does that represent? Is that the cost or is that the guest? Is what it is. I guess it's the other one.
That's the guess.
I didn't hear what you said.
The 42 is the guess.
42 is the slope.
Yeah, and so when you have a slope, it should be a rate, right? And so it should be like something per something. And so if we're looking at slope, it should be something per something.
Per guest.
Yeah, it should be cost per guess, right? And so your y variable is what? Cost. Your x variable is guessed. And so if you're talking about slope, it should be like the y per the x, right? Or the cost per the guessed. And the other thing, the y-intercept is what?
Zero and 750.
Uh-huh. Yeah, it's got it there. Yeah, 10 minutes in. Okay, I'm gonna make sure the other guys are doing their stuff. Y'all talk. I don't know what to tell you, but like talk amongst yourselves. Like you're both doing the same thing. I'm gonna jump somewhere else. Are we getting this? What problem are we on?
I'm on 5.
I'm on 5. Oh, I gotta catch up. Okay. Oops. I got that one wrong. I dropped down. I don't want to do it. Find the equation line that passes through the points -2, -6, and -4, 3. So what's the first thing you're doing?
And the slope.
Yeah, first thing you got to find a slope. What is that? 9 over -2? Is that what it is?
That's what I ended up with.
Yeah. So that's 2 of them. You got half your choices narrowed down. And after you find slope, you put it into where?
Point slope.
Yep, point slope. So what is it? Y plus 6 equals a -9/2 x minus 2. That's going to be +9. God. This is why you don't do things in your head. No, that's x plus 2. Yeah, my negatives are good enough. It's a -9. Okay. Ooh, which one is it? The -15 or the -3?
I got -15.
Yeah, it's it. So you got the other one, you're probably off by like a negative sign in there, is what I imagine. A lot of people are making that mistake when they plug things into point slope. They like would not account for the negative in the formula for some reason. I don't think you did that. I think you got it. They were scaring me though. It's like we're gonna have a test pretty soon.
Yeah, I did botch one of them by missing a negative. So yeah, I need to keep an eye out for that.
It happens occasionally. It's like as long as you're not just like doing it out of habit, you know, and like you actually understand the concept, you'll get a few more points than you know, not understanding it. But when you're consistently wrong, then it shows like you've mislearned it. Then you know I got to correct that. Okay. Any questions of what we're doing? Quiz horizontal and vertical lines. Oh. I don't want to talk about that. That was too easy. Is it a function? Y'all are doing the same thing. Talk amongst yourselves. Let me go bounce to another room, make sure they're doing what they're supposed to do. Where am I at? Where there? Let's go to 4.
That is, or I'm sorry, that's the range. The domain is actually going left to right. Sorry.
Hey man, y'all think you are ahead of me. Where y'all at?
Number 8.
Yeah, right ahead. Okay. What are you saying?
For the domain, I got -4, 1, and then range -5, 4, and it is a function.
Yeah. Which one is that? The orange one? I think so. I don't know if y'all's colors are the same. I don't think mine's the orange one. That's it.
Why isn't -2 part of the domain?
Going back on this.
Because it's
Let me do a
touching
screen.
one of the X points, right? So
Okay, so let me do this. Can you see my screen?
yeah.
My screen share?
Mm-hmm.
So you're talking about the domain? Is that what you said?
Yeah.
So domain, we're going left to right. We're reading the x-axis. So we're going left.
Right.
It goes to -4. When we go right, we're ending right here, right?
But what about where it loops there at the -2 X on the X-axis, and
Here?
it has
Oh, so we would account for this if we're doing intervals of increase and decrease, right?
Mhm.
Here, they just want the whole domain. Does that make sense?
because I mean I understand the 2 points to 2 ends of the line.
Mm-hmm.
What if it was a straight line? Could it be more than 2 points? 2 X's?
So if there's a break in the graph or something weird like that, but we haven't gotten to like piecewise functions or anything like that yet.
Because I remember finding domains and ranges that were more than just 2 numbers.
We found intervals that were more than 2 numbers, but I don't think we've done that and applied that to domain and range quite yet.
Okay.
That would look more like a piecewise function, which we haven't gotten to, which we will get to
Okay.
in good time. But we're looking here, and all we're looking at, we're just kind of, I'm like trying to put my hand up. I'm trying to put my hand up over this axis. Like if you put your finger up over this y-axis, just look at your x, and we look left to right. And so if you're looking at this thing, we're looking, it goes like up and down, but we don't really care too much. We're looking how far left does this go? And like the most left it goes is this number. The most right it goes is 1. But if you want to do like intervals of increase and decrease, you're absolutely right. Like the first interval of decrease would be like from -4 to -2, right?
Okay.
And then the increase would be from -2 to 1.
Okay.
Oh,
And
man.
if it had arrows at the end, it would be infinity.
Yes, and if there's an arrow at the end, it goes to infinity in that direction. So this direction's positive infinity, this direction's going to negative infinity. And we always read it like left to right. And so sometimes like if it's coming in from -infinity, that tends to really trip people up.
Okay, and you wouldn't stop. You would just go negative infinity to positive infinity, and you wouldn't do anything in between.
Yeah, as if there's
Right,
an arrow,
okay.
then you keep going to infinity. Yeah.
Okay.
And then when we do the range, we just put our finger over the x-axis, and we just look at the y-axis. So the furthest down this goes is -5. The furthest up it goes is 4. Now we're about to get thrown out of here. I didn't even look at the time limit, to be honest. Gotta unmute myself.
I think I did number 4. I think I picked the wrong answer in number 4. I was checking with a couple groups, and so if people are missing number 4, I think I picked the wrong answer. I always love it when I pick my own wrong answer.
Which one was that?
Number 4,
4.
I
Let me go
believe.
back.
Yeah. Can you go back?
Yeah, they lets us go back.
Okay. Oh yeah, they do. Well, doing.
Oh, I clicked something when I did number 4.
Yeah, I actually wrote down a question about this one because I wasn't
Yeah.
sure.
I think it should have been, if I think I picked the wrong one. It should have been, let me go on back to number 4. It should have been y equals -3/2 x plus 3. Not -3.
Okay. I kept on getting +2.
It's plus 3.
It's funny because I clicked on the wrong thing because I clicked on a solution just to get to the next problem.
Uh-huh.
And I totally clicked on the right one.
But that was really the wrong one?
No, I the actual right one.
Oh, okay, yeah.
Okay, so my question here was when we're figuring out the y-intercept of this, that -1 that's initially in this equation is left out. Is that correct?
On number 4?
Number 4.
Okay, so did you get the slope was -3/2?
Yes.
Okay, so then you say y minus 6 equals to -3/2 times x plus 2.
Yes.
And then you distribute that -3/2 and you get y minus 6 equals -3/2 x minus 3.
-3, correct. And
And
then
then you
there's
add-
still the
you add-
-1 at the end. But then we disregard that or what?
Where's the -1?
Okay, so if you look at this initial equation, when you simplify for y, you end up with -1. That's like your y-intercept there.
Oh yeah, we don't even think about that guy.
I'm totally.
We just want the slope from that line.
Oh, right. Once you found that line, you just throw it away.
Yeah.
Once you find the slope, you don't need that other line anymore.
Yeah, we don't care about the y-intercept. All we really care about is the slope on that guy.
Right, but we still ended up with a y-intercept for the solution. That's why I'm confused about the reasoning of us throwing away that -1, because like, why don't we just throw away the +3 or whatever at the end of the answer? Like, that's, I'm just, because,
a new line.
yeah.
Can I
Okay.
can I share my screen? Maybe.
Does it allow you to? I don't know. I think it allows co-hosts to.
Oh yeah, I can share my screen. Okay, here we go.
That was,
I'm gonna
yeah.
Okay, hold on. Okay, so the original problem was we want it perpendicular to 2x minus 3y equals 3, right?
Yeah, I'm not seeing your screen though.
Oh, you're not? Okay. Oh, because here we go. I forgot to share it. There we go. Now can you see it?
Yeah, it is.
Yeah.
Okay. And perpendicular to -2, 6. So first we have to find the slope here. So we just -3y equals -2x plus 3. And then y is going to equal to 2/3 x minus 1. And so we found the slope of the original line, right? Now this we don't need anymore. We just needed the slope. And so the slope of the perpendicular is going to be -3/2, right?
Okay.
And then we say y minus 6 equals -3/2 times x plus 2. Distribute that -3/2 and we get y minus 6 equals negative 3 halves x minus 3. And then we add 6 to both sides, and we get y equals negative 3 halves x plus 3. Does that answer your question?
Okay, yeah, so so we're disregarding this initial y-intercept because it's just parallel. So the
Right.
y-intercept no longer has any use
Yes.
because
We
it's
always-
just parallel is all that matters. Or I'm sorry, wait a minute, perpendicular, sorry.
Right, exactly. Once we find the slope, then we don't have any other need for that line.
Okay, yeah, I was trying to relate the two lines to each other, I guess, too much. I didn't understand that you can move them along the axes as much as you want to.
Yeah.
As long as they're perpendicular. So I guess that was kind of my, yeah, not understanding that.
You are a thinker. Sometimes you overthink
Yeah,
these a
bit
little
too
bit.
much.
That's okay.
Yeah, because I do get +3 as long as I throw away that
Right.
thing. So at least that works out.
Good.
Let me go back here. Oh darn! I accidentally clicked on an answer on number 9. Oh well.
So what are we doing now?
So did you want to go through, or did you want me to share my screen and go through?
Yeah, you do that.
Okay.
Okay, I'm coming on, I'm stopping my screen from being shared.
So I think screen share. What do we have? I think the other thing, like you could also do like maybe a Desmos might actually like show you a little bit what's happening there. Can I get this thing out of the way so I can do a new tab? Maybe. Okay. I don't know. Maybe I'm beating like a dead horse here. Y equals a 2/3 x minus 1, right? Was it minus 2/6 was the point? Minus 3 halves x, what, minus 3? Or was it 2 minus 6?
It was
It was a
negative.
positive. Oh, it's plus 3, huh?
Yeah.
Plus 3. Whoops.
There's the, yeah. There we go.
And so, like, well, if you think about, like, we have a line, there's going to be one line that's perpendicular to, like, these lines. But it doesn't really matter so much where this line intersects the y-axis. Like, if we were to change our intercept, it's still going to be perpendicular, right, to that line. And that line is still going to be perpendicular to this line, and it's going to go through that point. So it's kind of a weird thing. But we can actually shift that one line up and down, and it's still not going to change the problem. So that's a weird thing to think about. And to be honest, I didn't think about that being a factor before we started doing this. There's my game. Now, can I move this around and click the buttons I need to click while still on camera? So I don't know how far we got. I think most people got that. I think most people were getting like probably at least this far. Find the equation of the line that passes through what? Minus 2, minus 6, and minus 4, 3. So the first thing you have to do is what? What's the first thing you have to find if you don't have it?
The slope.
Yeah, so we have to find the slope is a what? -9/2.
Mhm.
And so we have 2 points to pick from, and we have a slope. And so if you have a point and a slope, guess what you can plug that thing into?
Point slope form.
Point slope form. There you go.
Don't you love how mathematicians name things exactly what they are?
Well, it's like it seems to be like really polar. It's either like something really simple, stupid, like point
Yeah,
and slope. You need a point or slope, where it's like some overly sophisticated
That's-
like
yeah,
Latin
yeah,
term,
right,
and
right.
it's like make you
That's-
sound pretentious as hell. But like,
right. True.
there's no middle ground or center.
So for that one, I don't know why I got +9. And then I got like -9/2x + 3.
Okay. So let's do. Let me switch my camera. Can you see my? Hopefully you see my camera, right?
Yep.
These are the 2
Yeah,
points.
thank you.
2 minus 1, x2 minus x, right? And so it really doesn't matter how you label your points as long as x1 goes with y1 and like x2 goes with y2. I'm probably just going to do it this way. But this is what we're plugging in, right? 4. Sometimes my 4s look a little bit like 9s. But this should be 3 minus. And we have a -6 here. This is -4. And we're going to subtract a -2. So I'm going to take care of the double negatives. 3 plus 6. And this is what? -4 plus 2. And so you should be getting +9 on top, but you should be getting a -2 on bottom. Is that what you said? I don't remember what you said now. You have to repeat it.
Yeah. And the other part to find where we do the y equals m, and then x minus 1 plus y1. And that one I got +9 minus 6.
So
Yeah, there.
this is the way you do your formula. Is that what you're saying?
Yeah.
That's what I heard. So that is the way to do it. That's not the way well, I showed it in the but like typically this book tries to do it the other way. They try to tag the y1 over here. But that's also a valid way to do it. So I'm not going to knock it. So this looks like what? -9/2 x. And now I have a negative. So which point did you plug in? Did you plug in this one?
The -2.
Yeah, the -2. So this is like a minus and -2, right? And we have to add a y1. So we add y1, which is a -6. So I want to bring this up because okay. Right now, like we would typically write it. There is a negative sign in this formula, right? This looks like y minus y1. So a lot of people, I don't know what exactly is going on in your brain, so I'm trying to predict maybe what you're thinking. But I'm not really sure what's happening. But there's a negative sign in this formula, right? And so there needs to be a negative sign when you carry this down. So people were doing just like trying to do negatives in their head too much or something, and they were not doing the negative in the formula. They were just saying something like y minus 6 or like x minus 2. It's like, no, there's 2 negatives there, right? This is going to be y plus 6. This is going to be x plus 2. So you have to account for the fact that there is a negative right here in the formula. So if your y is negative, you're going to end up with something that's plus here, right? If it was positive, you're going to end up with something that's minus here. And so those signs should be like opposite. And so you should do something like distribution here, -9x. This is a +2, and then we do a negative. This should make it what, -9. plus and minus 6. Is that what I'm... Okay, yeah, different problem. I got confused for a second. That should get you the correct thing, right? Is that what you're getting?
Okay, yeah, I'm seeing now. I'm seeing it.
It might be this thing. I didn't. Maybe I can like jump through it. It's 9.5 times x plus 2. I guess is the middle step I could put in there. Distribute this thing. These things should both be negative. If we're multiplying 2 by 9 divided by 2, it's just going to give us that 9 out of there. Any questions about this one? I think that pretty much got it, right? It's the solution. It's negative and going more negative. Okay, so I think I need to jump back over to screen share. Try to figure this thing out. Technology. Okay, next. So write the equation of the horizontal and vertical line that pass through -5, 2. So x equals a -5. Is that the horizontal or vertical?
Wait, what do you say?
Horizontal.
So x equals a -5. Is that going to give you a horizontal line or a vertical line?
Vertical line.
A 50-50 shot.
Horizontal, is it?
It should be vertical, right? If we go x equals 5. Okay. Can we do something like -5? So what does my -5 look like? Line look like? It looks like everywhere where my x is a -5, which is all along. Right. Okay, so I think I maybe said it. Yeah, I definitely said it in the notes. So like, we're creating a sort of grid when we do the Cartesian coordinate system, right? And so you can think of these things as x equals 0, x equals 1. So the line itself has to run up and down in order for it to measure left and right. So our x measures left and right, but it like the lines themselves, they look up and down, if that makes a little sense. It's how you grid things. The fly on the ceiling, right? Isn't that how he started?
Yeah, when he was sick in bed for,
Was that the story? He was sick in bed? Yeah.
yeah, and he just, yeah, did all this, come up with all this in his little brain.
Yeah, I mean, but there's also like a good deal of history. We're not really sure if it really kind of happened, and I think that's like one of the things. It's kind of fabled, right? It's like
A myth, yeah, fable.
yeah, it's like
Kind of a cool fable.
because there's a lot about like the Pythagoreans too, like the guy that suggested that irrational numbers existed, he didn't make it back in the boat.
No, he did not. I think that's true.
Yeah, I mean,
I think they thought it was a form of Satanism.
yeah, I mean, they were really like kind of like freaked out about it. And it's something that like, in this day and age, we just take like math to be this sort of like logical, like who could disagree with this sort of thing, but I guess I'm giving you all the solutions to these. But like people get really freaked out even when you suggest something that's true. I don't know. Buyer beware. I don't know what to tell you on that
Like
one.
they used to think the earth was flat. So,
Yeah. But there's a lot of people that knew better, like very anciently. But yeah, heliocentrism or whatever, or flat Earth was really popular for a long while.
But the history of mathematics is really fascinating.
But there was the ancient Greek. I don't think it was Archimedes. It might have been Archimedes. He did the thing where he looked at a well and saw the sun when the sun was directly over it, and he actually measured the circumference of the Earth like to a pretty accurate degree, like to almost like over 90%. Like he was pretty accurate, and he understood the Earth was round, you know. Like,
Right.
and so there were a great deal of people that actually understood the
Right.
Earth was
Well, you
round.
know-
It just like the other was also really popular.
And pi is in the Bible all over the place. And pi was actually, I mean, every culture, the Chinese, the Greeks, that came up with pi independently, but it's just so crazy to me. Anyway.
Yeah, and people have different sorts of notations to talk about the same concept too. Because I know there's an Indian mathematician, Ramanujan, I guess is the guy's name. And I think that's how you pronounce it. It was like he apparently learned in the dirt with a stick apparently, and like came up with his own notation. But yeah, he doesn't have quite a happy ending on his story. But he like lived in pretty good deal of poverty most of his life.
Mhm.
So does this represent a function? I guess I got it there. So what are we going to do to look if this is a function? So we're looking right here at 3. We're looking at -3. We're looking at this 5. And we're looking at this -5. So we're only looking at the x's. We look at them. We say, do any of those repeat? This one might give you a run for your money because they're giving you the positive and the negative, the positive and the negative. But none of those are repeating, right? So
And I did. You can tell I write these things because I left off my ending bracket, but that's okay.
Yeah. Okay, so that is good. I don't know how else to go over that. We have a few other problems that were like that. So give the domain and range of this thing. So the domain, I'm putting my finger over the y-axis, and I'm only looking at this axis. And so I'm going left to right. And so if I'm looking at this thing, it's going left, it's going left. It stops right here at a -4. And now I go right, I go right, I go right. It stops right here. I look down at the x-axis. This is at 1. So my domain should be from a -4 to 1. My range, I'm going bottom to top. So I look at this thing. It's going down. It's going down. It goes down. It comes back up. So it doesn't go down any further than this point. And so my finger's over the x-axis. I'm looking over here at my y-axis. This value is a -5. And so it goes up, it goes up, it goes up over here. Okay, but it goes up further over here. So we're looking over here where it goes up further. Where it goes up furthest is where we want to look. It is going up to 4. So my range is from a -5 to a 4. Is it a function? How do you know if it's a function? What's the test that we use?
Vertical line test.
Vertical line test. Thank you, Chelsea. Okay, so that's it. Questions about this? I think someone asked about, like, what about this thing? What about turnaround? So we're doing the intervals of increase and decrease. That's when we want to look at that thing, right? If we want to do intervals of decrease, it'd be like -4 to -2. If we do an interval of increase, it'd be like from -2 to 1. I could ask you something like that as well. It's fair game. Different concept though, right? Okay, so what's next? Did anybody get this far?
Can you go over this way?
Is that a response? You have to speak up a little bit. I can't hear.
Yeah, I
they
got this
wanted to
one.
go over it. Someone wanted to go over it.
Okay. Yeah, this is a good one to go over. A lot of people were struggling with this. So, what, 6 plus 2x? To find I'll do the silly stuff, I guess. Okay. So P of x is 6 minus 2x. If P of x minus 3. What do you see happening here? So everywhere there's an x, I want to plug in what now?
X minus 3.
Oh, I want to plug in the x minus 3. So I'm plugging it in. There's only one spot to plug in an x here. But instead of this thing, I want to plug in
Parentheses.
uh-huh. And what I want to write?
X minus 3.
X minus 3. And you totally ruined my surprise, but that's okay. I wanted to do this. If you do this, there's a good chance you're going to get this thing wrong, right? Don't do this. If you plug something in, trying to plug something in, I know we like parentheses a little too much, but here they really come in handy, right? Plug it in with some parentheses, because if you don't do parentheses, that's probably how you got one of those other answers that were on that list. You got to do some distribution. It has to get distributed. That 2 has to get distributed to both the x and that minus 3. This is 6. Minus and a minus 2 times 3 gives you positive 6. I see 6 and 6 is going to give me 12, and I have a minus 2x. I don't know if it's written in that order. I have to go look back at it. 12 minus 2x, or is it written as the minus 2x first? And the operation here is addition, subtraction. So I think some people are like struggling maybe with like flipping things that are subtraction and flipping them to addition.
On the game, it was saying that the right answer was negative 12.
Let's go look.
Could be. I hope not, but
Yeah, that one was tricky because it writes the thing about it, that the tricky is that it actually reverses the math that you did, but it is still the same answer. That's why I got it wrong also. It looks very similar, but you have to be careful with the signs. We're on
What?
number 9, right?
yeah. And you know what? So y'all won't have that problem on the test because you just write your answer. So you won't have to pick, you know.
Oh, so it's not going to be multiple choice.
Oh, no.
Okay.
Never. We're not allowed to give multiple choice tests.
But you see how it reversed it. It's a positive 12 minus x. Same thing, but it's tricky.
Never mind. I clicked wrong on that question.
Okay. All right, so we got that one. What's this one? Use the graph to find f of 0. So what is this 0? What does that represent? Oh.
The origin?
X value.
Is the x value. So if it if the x value of the origin 0, but this is just the x value of 0. So what does that mean? What is the x? What is the x value of 0? What is my function when my x value is 0?
-1.
So we're just going down here. We're looking when my x is 0 is all along the y-axis. So another way of asking this is like, what is my b or my y-intercept value, right? And I said this, but I hope you're looking at your homework, because a lot of people, like if I'm asking for f of 0, I'm asking for the number -1, right? But if I ask for a y-intercept, I'm looking for the point. I'm looking for the 0, -1. So I know a lot of people like it. And I was a little stickler on that one because they actually asked you those questions separately. So I was hoping you would get the formatting of them down on that assignment. So definitely go back and look at your homework assignments. Make sure you're getting like it's just a formatting issue. It's not even like a conceptual thing, to be honest, for the most part. And so I'll admit I'm being nitpicky on them, but sometimes you have to be a little bit. Use the graph to find all values of x from when f of x equals a -4. So they are really kind of leading you with this question. So I'm hoping if it's worded with this verbose intro, they're telling you we're looking for an x. If f of x is a -4, what is that like saying? F of x is equal to -4 is like saying,
Y equals -4.
yeah, exactly, right? Y equals a -4. So if y equals a -4, that's all along here, right here, where my y equals a -4. So where is my x when my function is a -4? How many times does that happen?
Twice.
It happens twice, so it's like right away you should be able to say, nope, it's one of these two. So if we're looking here, it hits here at a -1. That's definitely one of them. The other one is where? Right here at a
-3.
-3, yep. And so I think the -4 comes from the endpoint, right? But we're not looking at endpoints. We're looking at right along this line, right? And we look up at -1. We look here, we look up at -3. That's it. Intervals of increase. Okay, so we're looking here. We're going left to right, and we're asking where is this thing going up? So I think this is a bit more complicated than most of the stuff we had, to be honest. I don't think we had a piecewise until this thing.
I just had to find stuff.
Yeah, I mean, it works for the problem, and you should know it.
There is one like this on the test. It's just not quite that intricate.
So where's the important number? So -5 is an important number. Where else is an important number? A turnaround. So we go -5. -2, it turns around. Where else? Hopefully right there, -1, right? And I see also at what, 1? So if we're looking from -5 to -2, it looks like it's going up or down there.
Up.
Looks like it's going up. From -2 to -1, is it going up or down? I think someone said it, down. Someone say down? Or am I hearing things now? Might have been static, I don't know. It's hard to hear sometimes, y'all cut in and out, and it's like, did I hear static or did I hear the right answer? -1 to 1, is it going up or down?
Up.
Yeah, I think we're looking at this one right here. You told me it's going up from -5 to -2, and it's going up from -1 to 1. It's going down from -2 to what? -1, and it's going down from 1 to, it looks like it's going off to infinity there. List all the intercepts of this graph. So how many x-intercepts does this thing have?
When it hits the axes,
Yeah, so how many times does it hit the x-axis, right?
or any axis, right?
Yeah, any axis, but I'm asking more specifically right now just for how many times does it hit that x-axis?
I guess 3 times.
3 times. So you should have 3 x-intercepts. And how many times does it hit the y-axis?
Well, if
One
it hit
time.
anything that hits the origin, it hits both axes.
Yeah, and so we're looking for the origin in there. This one has the origin. That one says it doesn't hit the y-axis at all. It definitely hits the y-axis at the origin. So I think it's going to be this one even without looking at them. Just process of elimination, right? But we could look at them. It has a -2. It goes through 0, and it goes through 4 on the x-axis. -2, 0, 4 is there. I believe it's that one. Questions over that one? Do we need to go back over that? Does everyone see like where those are coming from, hopefully? Okay. 14, a 40-gallon bathtub that is full to the top drains at a rate of 6 gallons per minute. Write a formula G that models the number of gallons of water in the tub after T minutes. So we talked a little bit about this. This is the linear, like, problem-solving sort of thing. If I have a 40-gallon bathtub, what does that tell me? And it's full to the top. It has a full 40 gallons in that bathtub. What is that like? So we're starting with 40 gallons. Is that like a slope or is that like a y-intercept, I guess is the question.
That'll be your y-intercept.
That's like a y-intercept. That's the thing we're starting with. We're starting with 6. We're draining at 6 gallons per minute. What does that tell me? That's like a what?
The slope.
Yeah, it's like a slope. And it was draining at 6 gallons per minute. Well, it's going to be fully drained by 8 minutes, right? Can y'all figure that out? Do y'all? Maybe I'm going a little quick there. But 6 by 8 will give you 48 gallons, right? And so it should be done before 8 minutes. So you can think of things like that, maybe. But if it's draining at 6 gallons per minute, I think they're probably both on here. We get a -6x plus 40, or is it? No, I guess that option's not on here. Is it a -6x plus 40 or a positive 6x plus 40? I guess is the question.
Oh, yeah, that would have been a better distractor.
It is going to be minus because it's draining, right? And so hopefully you realize like one of those has to be positive, one of those has to be negative in order for them to work against each other. Are there any sort of questions about this thing? Oh, what am I doing? 6 times 7 is 42. That would be drained by 7 minutes. That's a horrible. I didn't do that math correctly in my head at all.
Well, I didn't notice.
No, I was like saying something out loud, trying to draw more like context to the problem, and I completely said the wrong thing. It should be like done within 7 minutes. 6 times 7 is 42. 6 times 6 would be what, 36? You'd have 4 gallons left.
Mm-hmm.
Yeah. Okay. So sometimes you can think about things. These are probably a little more straightforward than like things with what fractions with slopes and stuff like that might be a little more complicated. Any questions over this, over how we got these numbers, why we put this into our y-intercept, or why this one was a slope, or why it was negative? I'm hoping those are all things that like you're going to be able to do tomorrow.
And Matt wrote the test, and it's a very great test, and I went through it when I made this, and this is a good study material if you go back over it, because it does have a lot of the same types of questions.
This is implied domain and range, huh? Have we
Yeah.
done this? What do you think was implied domain and range?
It's on the test.
It is on the test?
Mhm.
But yeah, but the,
It's almost exactly that same question on the test.
okay. Yeah,
Now, so maybe we just want to say domain is the minutes and range is the whatever. Maybe I got too specific on this.
yeah, I think on the test it like divides evenly. This one doesn't divide quite so evenly.
Well, no, that's why I didn't.
Yeah.
We really didn't talk about the actual end. I mean, we haven't showed them how to set it equal to 0 and whatever, you know what I'm saying?
Yeah. Well, we showed about like x-intercepts and y-intercepts. They should be able to do that.
That's true. That's true. True.
Yeah. So they should be able to kind of figure it out. And I did mention it in the notes in the lecture. Like if we have a problem with that's like a real world problem, we don't want to go into like negative time, right? And so right away, I think all they say domain is time minutes from 0 to something, right? So all of them already have the 0 restriction on there. So my domain is starting at 0 seconds or 0 minutes. And how long is this thing gonna go? I think one of the options is it goes to 6 minutes. If it goes to 6 minutes, we've drained 36 gallons, right? That's not going to do all of it. And so what we want to do is we want to go from when the domain is 0 until there's no water left in the tub, right?
I was assuming that we had to, but you were right. You're totally right. They should be able to figure that out.
Yeah. The range is going from 0. Well, we can't go into a negative number of gallons in the tub, right? And so there's like this natural restriction that it has to be at least 0. And this is also coming from reality happens in the first quadrant quite often, right? The domain has to be greater than 0. The range has to be greater than 0. But they both have to be positive to happen in the first quadrant. We can't have more than 40 gallons in the tub. There's a natural sort of restriction happening there, right? All done. Okay. The next thing, and I'll be around. Are there any questions from this review?
We have 15 questions on the test.
10 questions, I believe.
10 questions on the test. Okay.
But they are multiple part questions. So. I think we've done most of these at some point today, right? Something similar. Graph the line of x equals 2. What's the slope of this thing? X equals 2. That's a weird thing.
Undefined.
That's the undefined slope. What's the slope of this thing? The y equals minus 3. That's the 0 slope. Yep. And so this, I believe, is a vertical. That's a horizontal line. We've talked about that. What's the x-intercept? How do I find the x-intercept? What do I plug in?
You can solve for y and then once you find the slope, or you can solve for x in the equation.
So what am I plugging in? You said solve for x, but what am I plugging in into the other thing?
0?
Yeah, 0 into my y, right? So anytime I think about x-intercept, the first thing in my mind is the other thing is 0. Anything I think about the y-intercept, oh man, the power of deduction right here, right? I think about the other thing being 0, x equals 0. And then I solve for my y. The other thing, what is that, 4? And y, we get 3x4. I want to put this thing as a point, and this is the thing that I was trying to drive home with the notation, right? I want the 0.40. I want the 0.0 minus. I want the point, right? I don't want just the number. When I ask for an intercept, I want the point. If I ask you to evaluate a function, then that's the number, right? What is the slope? So how would you find slope? Or what's probably the easiest way? There's a few ways.
Since you have x and y values, you can always just use a slope formula.
You can use, oh yeah, you can use a slope formula with your intercept, huh? You could do that. That's one way. What's another way? If we have this formula, what can we do with the formula? What's a really nice form to put it in?
Slope intercept.
Yeah, we put it in slope intercept. You should be able to grab the slope right off of that thing. Okay. Yep. Find the slope. I think most people are doing this correctly. Draw your little triangle if you have to. We gave you 2 points on there. So you should be able to count those things. I think some people were like not looking at the scale on the axis. That shouldn't be an issue on these because they're all by 1, right? Can you find the slope intercept of these things? So we did a few problems like this. So if they give you 2 points, we talked about this. The first thing you want to find if you don't have it is a slope. So you can find the slope between 2 points. You can plug those things in the point slope and hopefully do some algebra to solve for slope intercept. We talked about parallel and perpendicular lines today. So parallel lines, what kind of slopes do those things have? If I want a parallel line, it has what sort of slope to the line that's parallel to it?
Same as the original.
Exactly the same. We just take the slope, it is exactly the same. Perpendicular, what do you have to do to the slope?
Flip it and switch the sign.
Yep, flip it and negate it. So there's 2 things you have to do. So don't forget that. If we want to determine whether lines are parallel, perpendicular, or neither, these are in the same format, so those are probably not too bad. But what should we do to these things? What's like really going to throw you off if you don't do it? Like this isn't a good. This is a good format, but what about this?
Need to get the y by itself. Solve for y.
Solve for y. So y equals what? 3x. So we're looking at y equals 3x and y equals 3x minus 12. Well, what do you know about those lines? Are they parallel, perpendicular, or neither?
Parallel.
They're parallel. They have the same slope. And if I wanted to write a y-intercept, I don't see one there. But that just means it's a plus 0. It's going through the origin, right? Okay. The next one, are those parallel, perpendicular, or neither? They're set up perfectly.
Parallel, I'd say.
Neither.
So when I hear parallel and neither. So parallel, why would these or why would they not be parallel?
I say they would because you got one on positive and one's negative, and they both have the same. Well, the slopes are different, but the y-intercepts are the same.
Yeah, so they're going through the same y-intercept. One of them's positive, one of them's negative, right?
Right.
And so for them to be parallel, they have to be exactly the same. And so I think that's where they're trying to like throw you off a little bit here. So don't let them throw you off. This is like a positive, this is a negative. That is not the same number. They are not parallel. Are they perpendicular?
No.
No, because if they're perpendicular, you would have to flip it, right? There's no flip. There would be like a 2 over 1 or just the constant 2, right? Or like a whole number 2. So they're not parallel, they're not perpendicular. Guess what? They're neither. Parallel neither? And I'm not going to give you that last one. I'm going to let you do that one yourself.
And all the answers are on the bottom too, so you can check yourself.
I think we went through most everything. F of a -3. We've done this evaluating these things. So A and B, what number are they giving you? Is that an X or Y value?
X.
That's the X value. They want the correlating Y value. And these are the Y values. They want the correlating X values. Main range. Can you determine whether something's a function? If I give you a graph and ask you if it's a function, I'm not even sure what to say at that point, but like I hope that's a gimme for the most part. Is E a function?
I'd say,
Yes. Is F a function?
yeah, passes VLT.
Yeah, E passes the vertical line test. Does F pass it?
No.
No, definitely not. Okay, so what else? We didn't talk about this symbolically. Ooh.
I remember you mentioning like if it's squared or the exponent's higher than 1, then it can't be a function because it's a constant rate of change.
Oh, that's linear.
Oh.
So what you're talking about is linear. If there's like a square root or like an absolute value, then it's not linear, right? But function's something a little different.
But that's a good distinction. Sometimes I'm glad you said that, because you can have a function, of course, that is not a linear function. That's what we were kind of discussing yesterday. But yeah.
All right.
And so, like, I know this is going to be a line, right? 1/3 x minus 7. This is definitely linear over here. It's going to be a line. It's going to go through here at like a -7 and have like a 1/3 slope, right? Up 1/3. And so if I ask, it's kind of a silly thing because I know it's a line. Is this a function?
I'd say yes.
Yeah, it's absolutely a function. It's a linear function. I can be even more specific, right? But like it is a function. And so I think maybe the thing to do is maybe think about these things, their graphs. And so we talked a little bit about like the square root function. It looks like that sideways parabola. And so if we have the positive square root function, it's going to look like that. And so there's something kind of hidden in here, right? And so there's a thing that says y equals a positive root x, and there's a thing that also says y equals a negative root x. That's what that plus or minus sign means, right? It means we're getting two different results. And so we're doing the positive root x, it looks like that, and I'll talk a little bit about it, but if we do it root x, it looks like that. It's like the positive root x is like half the parabola, and the negative root x is like the other half of the parabola, right? Turned on its side, but it's still kind of like a parabola shape. And if we think about this graph, anytime we put in one x, how many y values are we going to get?
2.
Yeah, we're going to get 2 y values out of that thing. Is that a function?
Nope.
That is definitely. What do you say? Not a function?
Yeah.
Yeah, breaks the function definition, definitely, right? So we didn't talk about like what they look like symbolically, but if you get like a plus or minus sign, it's usually a good indicator you're getting like two solutions. It's not a function. So that one might be a little tricky. We've talked about what it looks like with these diagrams. I don't want to talk too much about those. But we've talked about that. It is past time if y'all got to go somewhere. Go ahead and go.
Yeah, make sure that you remember to log in, take the test tomorrow, starting at 9.
10, 11. We did something like 11 where you plug stuff in. 12, you should be able to find domain range of things, find intervals of increase and decrease. We've went over that. Six and 17. Any questions over anything on this? There's quite a few problems. I don't like intend to like go through all these. If you have questions, I'll go through them. Average rate of change, I don't think we need to do that, to be honest. I think we can kick 17 off. I don't think we had anything that complicated.
Okay, so the rule with domain and range is that each x has to have a separate y value, but a y value can have as many x values as it wants.
With the function, is that what you're asking?
Yeah, with the graph you look at, A and B. I get the rule backwards, or which one is which sometimes.
Yeah.
So if the A's and the B's, C's, D's, if that's all the X value, and then the 25, 36, 49, if that's all the Y value, what is that rule again?
So think of it like a Coke machine. Like these are the buttons and these are the product that you're getting, right? So if I hit a button, it's going to give me something. If I hit a button, it's going to give me something. I hit a button, it's going to give me the same thing, but this is like having two Coke buttons, right? It's just going to give you the same thing. So this would be a functioning machine, right? But if I did this one, like I'm hoping like you're like looking here or here, right? Like which one is breaking the function thing?
Okay, so when the X value starts to branch off into other Y values, that's when you would have the vertical line would pass through it twice, which would make it not a function.
Yeah, exactly.
Okay, got it. Okay.
And so think of maybe like a Coke machine. If I hit the button and it spits out this sometimes, or it spits out this the other times, right? It's not functioning right.
Yeah, because I get mixed up if I'm not looking at a graph sometimes. So
yeah, there's a really
hard to
horrible.
remember.
There's a really horrible, like sexist sort of way to describe the X and Y function thing too. I just don't really like it, to be honest. I just like try to avoid it.
What is it?
It's like the X's are males and the Y's are females. And so, like conventional dating, it's okay if like a male dates more than one female, but like a female dates more than one guy. Then, you know.
I've never heard that one, but
Yeah, it's archaic and sexist and horrible. So this one's okay. But if you want to think about those horrible tropes and if they help you, whatever, I don't know. As long as you don't put too much credence into them, I think you'll be okay. Well, before, I was confused with the numbering there. Okay. Yeah, like I said, I wouldn't worry about 17 too much. We didn't. could probably like figure out how to do that, but it's a little complicated. When I don't think we had anything like that complicated. 18 looks good. 19. Well, all this stuff looks pretty good. 21 looks good. Ugh. 22, 23, this all look good. Uh, 24 looks fair. $25 might be like a little new, right? So 25, how do you know if it models it exactly or approximately?
Well, we have to like find the pattern of change, right?
Well, they give you
each one?
they give you the function, right? And so you don't really have to figure out any sort of. You could look at the slope here if you want to do that. Is that what you're saying?
Well, that looks like the one where we were going from top. The first we'd look at the top and then the bottom, and we'd see the rate of change.
Yeah,
Or am I
yeah.
looking at it
You
wrong?
could do that. That's a way to do it. Yeah. And then you can see if this equals 3.5 each time. I would just like plug this in to my calculator. Probably is what I'd do. I'd be lazy about it. 3.5 times 1 minus 5.8. Does that give me that number? Right? Do y'all do this stuff or no? I don't know. 3.5 and an x, and I do minus like 5.8. You just go look at a table, right? Maybe I'm being lazy. Second graph will give me a table. I need to see if those are on par. Minus 2.3, 1.2, 4.7, 8.2, 11.7. Looks like it. Looks like it's exact.
Okay, so but if we want to plug it in, like let's take the first one, which would be x is 1, fx is negative 2.3. So fx would be put on the left side of this equation, right? Negative 2.3. Correct?
I'm not sure. I'm exactly sure what you're asking, but if I do
Okay.
3.5 times 1 minus 5.8 is the first thing that I'm doing, right?
Yes,
do the
but
same.
negative 2.3, which is what it says fx is on the same.
Yeah, that's my y
box.
quantity. Yeah.
Yeah, that's what I'm saying. So you're solving equations at this point with just numbers because you're plugging in the values for.
Yeah.
Because all these parentheses with x's is throwing me off sometimes without the context of like the f function thing. You know, because it's real easy to just look at the x and go, oh, okay, well that x, I'll just plug in a 1 on that side, and then on the other side I'll plug in a 1. So you have to be careful about what you're plugging in and stuff. You know,
Yeah, so
given the situation.
f of 2 will be 1.2, right? Is another way to think about it. You can also go the calculator if you go to like variables and you go over to y variables. You can actually pull up that function that's like in your y1. You can actually evaluate things at certain numbers too in your calculator. So f of 2 equals 1.2, right? You can get those numbers that way as well. It's probably like that's a lot of work probably to get it at this point. But when we get some more complicated functions, like it might come into handy to be able to like plug in a specific number really quick. And then write a formula that models it. So this is like you were saying, right? You're saying find the change here, find the change here. plus 10. So what's my slope here? That's the first thing I'm going to ask. Is he still around? Michael's still around or no?
Oh, the slope
Uh-huh. Be careful here. Because this is where...
is, well, don't we have to go through the whole thing here?
You can. It's going to be the same thing on this one. It's not being tricky on this one.
Yeah, because I mean, I'm
Linear.
figuring some of these might just be like no solution or something. I mean,
This
I
one
guess
is
that-
linear, and they set it up linear so that it wouldn't be a
Yeah.
problem.
Matt, 2/10 is 1/5.
Mm. What is your
Correct.
slope?
Okay, so it's rise over run, so x would actually be at the bottom.
Uh-huh.
So that'll be 2.
So what's the change in the y?
What? Oh, you're doing deltas. Okay.
Yeah, sorry.
X is 1 at the bottom. And
What?
then at the top would be a 5. Isn't that correct?
Yeah, I was going to 10 and 2, 5 and 1. That's it.
Yeah, so 5. Yeah, slope is 5.
Yep.
Okay, so the slope is 5, so we still need to get the entire equation, I guess.
Yeah, so y equals 5x plus what?
Plus b. What's b?
That should be one of the easy things to get out of here. They do give it to you.
I think it's several. I mean, it could be any of those fx numbers, couldn't it?
No. B means a really specific one. It's your y-intercept.
Yeah, it's the y-intercept. Okay.
So what's your y-intercept here?
Let's see here. 1. It's not the x's. That's not the right one. It's the fx.
Mhm.
Yeah. If it's not the separate numbers, it'd have to be the 10, because that's how it's changing. But if it's 5/1, then I don't know if that would work.
0, comma b when we write it out as an ordered pair, right?
Correct.
So which one of these things? The 0 represents what now?
The x-axis.
What value though? It's not the
0.
x-axis, it's the y-axis, right? But this is when your x is
X is 0.
when x is 0.
Okay, so on that chart, then that would match up to 6. Okay.
Yeah, that's it. That's it. That's what I was looking for. You're looking for your y-intercept there. So hopefully they give you it. If not, then you have to do a point. Like if they didn't give you like do point 4 or something, and you have to go to point enter point slope point slope. That's it.
What if those numbers are not adding up evenly? Do you just put no solution or what?
Then it's not linear, and that would be kind of a jerk question to ask because they asked you to write a formula for the linear function, right?
Right.
And so they in the question they imply this thing is linear, and they imply that it should work out with a constant slope. And if it doesn't work out with a constant slope, then it's not linear. All right, I think we hit stop on